Hi friends, welcome to my channel, and today we will discuss HCF, how we are going to solve for this particular series of numbers, how we are going to solve HCF. So what is HCF? Highest common factor. So what we are going to write it here is, see, for example, each and every series is written in the form of the prime factors. Okay, now what are the common factors here? 2 is there, 3 is there, 5 is there, 7 is there. 2, 3, 5, 7, 2, 5, 7. So common is 2, 5, 7. Now whenever we try to find out HCF, we are going to take least powers and their products. Least power means for 2, what is the least power? 3, 2, 3. Least power is 2. For 5, what is the least power? 1. For 7, what is the least power? 2. So product of all these things. This is 4 times 5 times 49. So this is around, how much it comes? 980. Okay. So what we are trying to identify here is, in the highest common factor, this is called factorization method. Okay, HCF can be solved with the factorization method as well as with the division method. In the factorization method, what we have identified is, any number which gives, we write in the product of prime factors and the least powers we will take, and we will multiply it to get the HCF of a particular series. So this is one example, friends. The next one is, for example, there is another number series 108, 288 and 360. Let us write each and every number in the product of prime factors. So let us start with 2 and 3 first. Okay, 2 and 3. So 2 power 2 and 3 power 3. Then it will give you 108. Every product of the numbers we will write with the least prime factors. We will start with, so 2 and 5, 2 and 3 we will try. See, for example, 2 power 5 and 3 power 2. Then 360 we will write 2, 3, 5. So 2 power 3, 3 power 2, 5 power 1. So this is the notation of the writing of the prime factors. Now, what are the common prime factors here? 2 and 3, right? 2 and 3. What are the least squares of 2 and 3? 2. And for 3 it is 2. So what is the value here? 2 power 2 and 3 power 2, that is 36. Like this we try to identify HCF in a simple format, and this is called the factorization method. Now we can also solve the HCF by using the division method. What do you mean by division method? So we will check with one example. For example, if we are going to find out the HCF for 513, 1134 and 1215, first we will try to take the HCF for these two, 1134 and 1215. So let us take 1134 divisible by 1215. One time it is 1134. So what is the remainder? Remainder is 81. Then again we will solve with this. 81 times 14, we will get 1134. So 81 is the HCF for 1134 and 1215. Then 81 and 513 HCF we need to find for these two, 81 and 513. So 81 6 486. The remaining will be 27. And 27 times 3 is 81. So HCF will be 27. It means for the total series HCF is the 27. So this is called the division method. So there are two methods. One is the division method, then the other one is the factorization method. So this is how we are going to solve the HCF for the given numbers. Okay. So next one is, let us try to understand how we are going to find out the LCM. So what do you mean by LCM? LCM is least common multiple. So how we are going to solve the LCM? We will take with an example. LCM of 2 power 2, 3 power 3, 5, 7 power 2, 2 power 3, 3 power 2, 5 power 2, 7 power 4, 2, 3, 5 power 3, 7 and 11. So this is a given series, friends. Now we are going to take the factors. How many factors are there? 2, 3, 5, 7 and 11. We'll take all 2, 3, 5, 7 and 11. What are the highest powers of all these factors? Highest power of 2 is 3. Highest power of 3 is 3. Highest power of 5 is 3. Highest power of 7 is 4. Highest power of 11 is 1. So when we multiply all these things, we are going to get the LCM. So in a similar way, we try to find out the LCM for 72, 108 and 2100. 72 we write product of prime factors, 108 and 2100 also we write the product of prime factors. 72 let us write 2 power 3 and 3 power 2. 108 2 power 2 and 3 power 3. 2100 is, let us say, 2, 3, 5 and 7. So 3 power 5 power 2. So 2 power 2 is 4 times 3 times 25 times 7. 12 is there. Okay. So 21 is there. So 25 times 4 is 100. 7 times 3 is 21. So 2100. That's why we have written 2357. So this is the concept of writing into the multiples of prime factors. So try to solve this one and we are going to get the LCM for all these numbers. For example, the LCM can be taken as all 2, 3, 5 and 7. Highest powers 3, 3, 2, 1, right? So 2 power 3, 3 power 3, 5 power 2 and 7 power 1. So the product of this is 37,800. So this is the way how we are going to calculate the LCM, least common multiple for. So this is called factorization method. There are two methods for LCM as well as for HCF. For HCF, factorization method is there, division method is there. For LCM also, factorization method is there and the division method is there. So let us take another example with the division method. For example, if there is a LCM of, we need to find out the LCM for 16, for 24, 36 and 54. So how we are going to find it? So this is by the division method. In division method, what we are going to do is, see, it is commonly multiplied by 2. So 2, 8, 12, 18, this one will be 27. Okay. So again I'll take 2 times 4, 6, 9. 27 is not divisible by 2, so I'll take as it is 27 to the next step. Again I'll take 2, 3, 9 is not divisible, so I'll take it as it is. 27 is also not divisible. Then now I'll take 3. So 2 as it is I will take. 3 means 1. So 9 means 3. 27 means 9. Then again I'll take 3. So remaining is 2 as it is I'll take. 1 as it is I'll take. 3 divided by 3, 1. 9 divided by 3 is 3. Like this. So now what is the LCM? So LCM will be the product of this side as well as this side. That is 2 times, 2 times, 2 times, 3 times, 3 times, 2 times 3. So 2 times 2, 4, 8. So total will be 432. So like this, LCM can be identified. So thank you for watching this video. If you like this video, please subscribe, like and share. Thank you. Hi friends, welcome to my channel. So next one is we have to find HCF and LCM for the fractions. So for example, HCF of given fractions is equal to, what we are going to find is HCF of numerators. What are the numerators? 2, 8, 16 and 10 divided by LCM of denominators 3, 9, 81 and 27. So for example, 2, 8, 16 and 10. So what is the HCF of all these numbers? Highest common factor is 2. Then come to LCM, 3, 9, 81, 27. So LCM is how much? 3 times 3. Then here it will be 3 times 2. So remaining is 21. Then here it is 9. So this will be 1, then 9, then 3. So this will be like this. So how much it will be? Around 81. So 3 times 3, 9, 27, 3, 81. So this will be 2 divided by 81. Then, so this is one type of understanding for HCF. Whenever there is HCF of fractions is equal to HCF of numerators divided by LCM of denominators. For example, if this is LCM, what happens is here we'll take LCM and here we'll take HCF. So in the same way, for example, LCM of 2, 8, 16 and 10. So how much it comes around? In the previous method, if we do, it comes around 80. Similarly, HCF of 3, 9, 81 and 27. 3 means we can write it in the factors, right? Powers. So 3, that is 3 power 2, 3 power 3 and 3 power 4. So HCF is nothing but least power, that is 3, right? So HCF is 3. So this is now how much? 80 divided by 3, like this. So we can identify like this HCF and LCM when there is a fractions. So LCM we find with the division method, HCF we find with the factorization method. We have written in the prime factors: 3 times 1 3, 3 times 2 9, 3 times 3 81, 3 times, sorry, it will be 3 times 3 is 27, 3 times 4 is 81. So the least power is, among all 3 is common, so least power is 1, means 3 is the HCF. So this is one type of notation with respect to finding of the HCF and LCM for the fractions. So the next one is, if there is a decimals, how we are going to solve HCF and LCM if there are decimals? For example, 0.63 is given, 1.05 is given, and also 2.1 is given. So now we are going to change this into the normal numbers. Then 65, 63, 105 and 210. So now what we are going to find is, we are going to take it as a HCF. So you can find HCF of these two by division method, and also LCM of these by division method. So then, for example, HCF, if I calculate for this, how much it comes around? This comes around 21, and LCM, if I found with the same method, division method, I will get around 630. But this is for normal numbers, and I have to convert this into the decimals. So when I want to convert this into the decimals, it becomes 0.21 and this becomes 6.30. So this is a method when there is a decimals. So decimals are converted into the normal numbers, and after that you can find HCF by using the prime factors. If it can be expressed in the prime factors, you can find HCF in the prime factors, or else you can go for the division method, then you will get 21. LCM also you can get either factor method or you can get division method, and you will get 630 for this particular series. So from that you can derive the HCF and LCF for the numbers. So this is a kind of understanding with respect to LCM and HCF. And let us say, for example, I have given a sequence of fractions: 17 divided by 18, 31 divided by 36, 43 divided by 45, 59 divided by 60. So now what I am going to do is, I just want to arrange this into the ascending order. So this series, for example, this series is in the fractions. I am going to make it in the ascending order. Okay. Ascending order means increasing order. So what I'm going to do is, for example, first for the denominators I'm going to find the LCM. What are the denominators? 18, 36, 45 and 60. Okay, for this I'm going to find the LCM of all these things. So the LCM for all these things, if I do with a common factor, I'll get around 180. LCM of denominators. Okay, 180. So now what I'm going to write this is, I'm going to write it into a common fractions of all the numbers. So now what I'm going to do is, I'll just write 17 divided by 18 as 17 into 10 divided by 18 into 10. Okay, because since my LCM is 180, so I'm going to take it 180. How I'll get 180? If 17, 18 I have to multiply by 10. So in the numerator also I have to do the same, so that the value cannot change. Then similarly 31 divided by 36. So similarly, how much I have to insert in order to make 180? So 36 times 5 is 180. So 36 times 5, same I am going to apply 31 times 5. Then similarly, the next one is 43 divided by 45. So how many times 45 became 180? It is 4 times. Similarly, 59 divided by 60. How many times 60? If I add it become 180? 3. So I'll take 3. So like this. So now how much amount comes around 180 divided by 180? So now all the denominators are similar. So 180, 170 divided by 180. Then the next one will be 100. So 31 times 5. So how much it comes around? You can get it around 155, right? 155 divided by 180. Then next one is 172 divided by 180. And the next one is 177 divided by 180. So if you cannot watch this, I'll just write it on the top. So 170 divided by 180, 155 divided by 180, 172 divided by 180, 177 divided by 180. So now I have all the denominators are similar. So I am going to write in the ascending order, that is 155 less than 170 less than 172 less than 177. So in the same case, 155 divided by 180, 180, 180 will also be same. If this is the same, 155 is associated with 31 divided by 36, 17 divided by 18, 43 divided by 45 and 59 divided by 60, because 155 180 means 31 divided by 16, right, in the previous calculation. Similarly, this belongs to this belongs to this belongs to this. So same notation we have applied to the fractions and also. So like this we are going to find the ascending order, and you can also make it for the descending order. So like this we will take some of the examples of LCM and HCF. So thank you for watching this video. If you like this video, please subscribe to my channel, share it and like it. Thank you.